Hello everyone. Myself Dr. Pratibha MK, Associate Professor, ATMA College of Engineering, Mysore. Today I am going to explain the 4th semester microcontroller lab program. Before writing the program, you must know the how microcontroller performs addition operation. So the fifth program of the syllabus is like this. Write an 8051 ALP to add the byte in RAM at 34H and 35H. Store the result in the register R5 which holds the LSB byte of the result and R6 which holds the MSB byte of result using indirect addressing mode. Using indirect addressing mode. So let us consider two examples. Okay, one example is you are carrying a boat without without generating and carry, and another example is after the addition the carry will be generated. So in this case, first case, whenever you are adding 80 plus 42, the carry is not generated. In microcontroller, each digit is represented by a 4-bit in the BCD form. For example, the 8 is represented as 1000 and 0 is represented as 4 zeros. That is, every decimal digit is represented by a bits. So it performs the binary addition. 0 plus 0 is 0, 0 plus 1 is 1, and like that it will be carried out till 8 bit. After that, starting from the least significant bit, it will group the 4 bits together and obtain the digit form. So if you group 4 bits, 0010 is nothing but it represents 2. Similarly, 1100, the bit weight position of first bit is 8, second bit is 4. So 8 plus 4 is 12. In decimal, in hexadecimal, it will be represented by C. Or after performing the addition, the result will be represented in the form of an hexadecimal form. Here, as per as given instruction, the R6 register holds the MSB byte of result. In this case, MSB byte is 00. So R6 is equal to 00H. Whereas R5 holds the LSB byte of result, that is C2 is storing in R5. Similarly, in this case, carry is not generated. That's why MSB bit result will be stored as 00. Whereas if you consider the second case, after adding these two numbers, FFH, you are going to get the carry. So the MSB bit in the position of MSB byte, we are going to store the carry, that is 01. FE will be stored in LSB, that is in the R5 register. So it is not mandatory you have to store the result in R5 and R6. If they mentioned, you can use R5 and R6. Otherwise, register from the R2 to R7 you can use. If they have not mentioned any particular register, you can use the other register also. So here this is a program used to perform the byte addition. So this program starts by loading the R0 register with the address of RAM location 34H. It then indirect addressing mode to access the byte at 34H and then add at the 35H. So the result will be stored in R5 and R6. So in this case, the two data will be stored at 34, that will be transferred to accumulator, first memory location data, then memory location will be incremented to 35, and later on it will be added. Before that, in order to store the carry, register R6 is initialized. So after addition, if there is no carry, only the result has to be stored in R5. So if it is no carry, you have to move to the specified label. In the specified label, what we are going to do? We are going to store the lower byte of the result. If carry is generated, depending upon the data given, you have to increment the MSP result. Then at the end, you have to indicate the logical end of the program. This is about the brief explanation of the program. Now let us consider how to execute this program by using a IDE, that is Integrated Development Tool. Keil Micro version 3 we are using. So in this case, first you have to create a folder on the desktop with your convenience. So in that folder, just to create a separate folder for each experiment. Now I am executing the 5th experiment. So I will give the folder name as experiment number 5. Then once the folder has been created on the desktop, then open your tool, ID tool, then create the new project. So create the new project. In the new project, you have to give the name, that is nothing but I am going to give project 5. Whatever the experiment, I am going to give the same project file name. So that you have to be stored on the desktop experiment. You have created a folder, no, experiment file. In that you have to store it. Once you have stored it, you will get the window to select the device for the target. So this tool will support many chips. So but we are working on 8051. So that particular chip has to be selected. So once you select the chip, the corresponding detail will be appearing in the description window. So our interested chip is 89C51ED2. Once you select the chip, its description hardware component or hardware configuration will be appear under the description window. Then save the content. It will ask whether we have to open the created project. Then just to select yes. So the target will be created under the project workspace. So once you have created, next step is you have to write the program. So for that, go to the toolbar, file, and then select new. So the editor will be come. So once the editor will come, you have to write the program. So what is the program? I want to add the two numbers which is located at 34 and 35, and result has to be stored. So already I have typed on the Windows. So that program, whatever the program I have explained, the same thing has been typed on the editor window. Afterwards, this program, whatever you have typed, that has to be stored by using a file tab, and you have to save it. Where you have to save? You have to save the program in the created folder, that is experiment file. So the program should be stored by using a file name, and it should be separated or it should be attached with .asm. File name should be followed with .asm. Okay, if you forget, if you not included the .asm, then you will get an error. So then you have to store it. Where you are saving the file, that is in the created folder. It is on the desktop. Now, whatever the program you have stored on the desktop, that should be transferred to ID, that is Keel Microversion tool. That should be added. That can be done by using a source group. Just to right click on that, then copy the file or transfer the file from the folder to ID tool. So again the control will goes to your folder experiment 5. So actually it is not displaying anything. You have to select all files. In that you have to select .asm file and select click. After that close it. So once you select that .asm file will get included on the Microvision tool. Afterwards, you have to check whether any error has been occurred while writing the program. So that can be done by using a build target. So that can be done using project and then build target. So the tool will check whether any error has been occurred or not. Here you observe that 0 errors and there will be a 3 warning, so that you can ignore that, it is not an issue. Okay, so 0 errors. Suppose if there is any error occurs at this stage, you have to go back to your program and you have to you have to identify the error, rectify it. Once again you have to save the file and once again you have to build the target. So this process has to be continued until you have to get the 0 error. Once the program is error free, then you have to set up for the debugging. So that can be obtained by selecting the toolbar debug, start and stop debug. So it will ask, it is an evaluation version. It can run code of size limit of 2K. So it will ask this one, you can select OK. Once the OK has been clicked, you observe that on the left hand side you will get project workspace. So in that you are going to get the registers of register bank. You know that there are 8 registers from R0 to R7. So initially all the register content will be 0, 0. And also it consists of, it indicates the values of general purpose register AB, its content is 0, 0. And wherever plus symbol is there, just to enlarge that, you will get DPH and DPL, lower order and higher order byte. That indicates that excuse me, you can access data pointer either for 16-bit operation or 8-bit operation. And below that you have a processor status word. It indicates the various status of the flags. Before execution of the program, all the values register and processor status word is 0, only except stop pointer register is 0, 7. By default, SP will set to 0, 7. Now you have to execute the program. So once again go to debug and then run. So it will run the program. Here you have to, before running the program, you have to indicate the memory location. So what you have to do, suppose if you forget, if you are not giving the memory location, just to stop running, then it will stop. You can build, you can go to debug, okay, debug, then start and stop running. Okay, so if you are not giving the thing, just you have to stop running. Okay, then okay. So before execution of this, you have to indicate the memory location. What is this memory location? 34. So whenever you want to give the memory location, it should be indicated. If it is an internal, it should be start with D followed by colon 0 x, okay, 0 x 0. What is the starting address of memory location? 34. Enter. Now this space, this window is called as a memory window. Initially it will be filled up with 0, 0. And stop pointer register is filled up with 0, 7, and some other data bit has been defined in this particular location that is reserved for some application. So in this case, what you have to give the data. So in the example I have explained 80 and 42. So select this one. The first number is 80 and second number is 42. Okay, where the result, this is the 80 should be added with 42, and then result will be stored in R5 and R6. R5 holds the least significant byte, R6 holds the most significant byte. So now after giving the data, you have to run the program. So once you run the program, okay, once you run the program, the result will not be indicated. So in order to update the result, what you have to do? Debug, again stop running. So after running, if you stop it, you will get the result at R0. Okay, so at R5 it is storing the C2, at R6 0, 0. So as per as in the PPT, whatever the result I am getting, same values are getting. Suppose if you want to change the data, if you want to change the data, for that start and stop the debug session. Once again, if you want to give the data, again debug, start and stop. So okay, then I will give the FF as the data. So this number will generate the carry. R6 will contain 1. Now once the data is given, debug, run. So after running, R6 and R5 is not, the values has not been updated. So in order to update, what you have to do? You have to stop running. Once you have stopped running, you will get the updated result. As per as explanation, R5 consists of FE and R6 consists of 0, 0. So I hope all of you are understood this program. Okay, thank you for watching. So after ending of this program, so you should not close the tool immediately. You have to go to file and then exit. That is very important. Then tool will be closed. Thank you for your